Hello, this is Alan Roble again, continuing my series of videos on the ECL language. This time I thought I'd do a short series on distribution of data on the HPCC systems. So firstly, what is this construct or idea of distribution? Well, Thor is an HPCC architecture, high performance computing cluster, and the word cluster is a bit of a giveaway on the architecture. So Thor is a single entity, but it runs distinct on a number of distinct computers or boxes or nodes. So the idea is behind HPCC is to take the code to the data. So you'll compile some work unit that will compile into a library, a .so file, which is then copied to each node, and then that can execute on the data on that particular node. Only when the results, intermediate results for any node are calculated, they then the last final global operation produces the final results. Right, so that's the architecture. And what you ultimately want to do, what you're aiming to do all the time, to leverage as much as possible of HPCC as you can, is to get an even distribution as possible over all the physical footprint to be even for a single logical file over all the nodes. And in that way, the amount of processing done on each node is roughly balanced. So how do we start? So loading data into Thor is a spray operation, and that will distribute the sprayed file over all the nodes, but it does it in an unintelligent fashion. It doesn't know anything about the data. There's no control of spraying that you have with these spray operations. It really just does a dumb spread. It does what it says, sprays basically. And what you have to do, your job, as you know the data, is to decide what fields in the data you can hash on to ensure that the individual physical footprints for this single logical file on every one node are roughly the same. When they're not the same, the amount of difference is termed SKEW, and I'll get back to that later. Right, so you've sprayed in a file, you've then want to distribute it because in an intelligent fashion. So the ECL here to do that is, if you've got some files, just distribute. And there's all sorts of different hashing functions you could use. For example, surname, first name might be adequate, but you yourself would have to find that out. For example, a very silly distribution, if you just distribute by a constant 1, obviously that would mean that all the data would end up on a single node, and really that's a very silly example, but it just shows the mapping between what you're doing with distributes and the physical layout. Let's Control Z that, because that is very daft indeed. What happens, you can actually run globally, so there's nothing to stop you running, processing the entire logical file in one go. But really, you're not leveraging the power of HPCC, so it's going to be slower, and you could well crash with exceeding SKEW limits. So whenever you're processing globally, HPCC all the time is monitoring the amount of use you make on each node, and if it gets too disparate, then it will crash your work unit with SKEW exceeded. It won't do it obviously if you're running locally, which is what you want to do. But I better give you a definition of SKEW, as what we're trying to do is avoid this. So in my particular example, if I've taken these as my size, I've said the average is 7 for the physical footprints for this particular file, then the SKEW is defined as the maximum of the absolute of the average partition size minus partition size divided by average size. For example, in this node here, the smallest 4, so the here you've got a average size of 7 for the entire file. This particular node only contains size 4, so divided by 7 is 42%. Now this one here generates would be negative, but would be 7 minus 12 divided by 7, and that generates a skew of 71%. Now normally I think the default is 10%, but I'm not absolutely sure about that. So if I ran any work unit against that, a logical file distributed like that, it definitely would crash with skew exceeded, really. So this is something you want to avoid. Okay, so really, to leverage the power of HPCC, you're processing of a logical file is a two-stage process. You want to do the heavy lifting to get intermediate results locally, and then as a second separate stage, take these intermediate results, be a very small operation, to then run a minor operation to just aggregate your intermediate results into a final result here. So for example, if there were people here and you had the ages here, so I want to find the average age from this entire logical file, I would count the number of people on node 4, and I would sum up their ages, and I'd do that locally on each individual node, and then at the end I would just sum the count of people and sum the sums of the ages and do the division there. So that's how you're supposed to use HPCC, and I think I'll get on to an example of how to do that in another video, but at the moment I think that will do for this particular video. Cheers, bye.